Hi everyone. So the purpose of this video is to help you understand why the unit circle or where these values come from. Okay, so now I just want to remind you. I know I went over how to memorize it, but what are you memorizing? The unit circle is studying. Okay, well, sorry. Let me go over that. So we have the unit circle here. We have a central angle. Every point on the unit circle is giving you, it's not just a random coordinate or random point, it's giving you the cosine and the sine of this angle. Okay, so we didn't get a chance to start the functions, but this is helpful for solving equations or looking at functions, the sine function, cosine function. Now, I'll just give you one example. So for example, if you look at the unit circle, at pi over 4 radians, so if this here was pi over 4, why are the coordinates root 2 over 2 and root 2 over 2? In order to understand that, we need to go away from the circle and look at a special right triangle. Okay, so I'll give you a little hint here. See, this is where the right triangle comes from. So we're looking at not any right triangle, a special right triangle. The special right triangle that I'm looking at is the isosceles one, which means that we have two equal sides and two equal angles, and opposite two equal angles are equal sides. Since we're looking at the unit circle, we actually already know the hypotenuse. The hypotenuse here is 1. So we're looking at triangles whose hypotenuse is 1. Now, just quickly a review. So we're talking about cosine and sine. So let me remind you that the cosine is the ratio, that's all it is. It's a ratio between sides. And the sine is also a ratio between sides. Which means that in order for this angle to be 45 degrees, this has to be a certain size with respect to 1. Okay, so it can just be any size. If not, you're not creating this isosceles triangle. Now, what are these values? Luckily, we can use the Pythagorean theorem. This is a right triangle. We already know the hypotenuse. We know these are equal sides, so really, we're only solving for one unknown, which is extremely helpful. Which means that in order to have an isosceles triangle with hypotenuse of 1, the other two sides must be this, except that is not rationalized. Well, first let's simplify it. The square root of 1 is 1, square root of 2, irrational. I want to irrational denominator. I want to rationalize the denominator, which is where we get the first value. What this is saying a few things, but first, in terms of sides, an isosceles right triangle, so 45 degrees here, must have opposite and adjacent equal sides. So the smallest unit, we're going to use 1, shows you where the ratio comes from. Because if I look at the cosine of 45 degrees, that's adjacent, the square root of 2 over 2 over 1. But we don't need the 1, obviously. The square root of 2 over 2. If you look on your calculator, that your calculator has been programmed to this. Now, obviously we don't only study, when you study trigonometries, the hypotenuse was actually rarely 1. But this is just showing, so if the hypotenuse is 15, if you reduce all the sides, you would divide everything by 15, the ratio would still hold. So this is a ratio. And the sine is the same thing because they're equal sides, right? So if we're looking at the sine of this angle, opposite the sine of this angle, and so on. So on the unit circle, 45 degrees is actually pi over 4. So let me see if I can, before starting another page, just go over that here. So that's why, if we look at the unit circle, if we look at pi over 4, those coordinates are actually the lengths of a right triangle. So in order for you to get here, right, how would I arrive here? I just realized that if my hypotenuse is 1, I just solved for these lengths. In order for me to get to this point, I have to travel root 2 over 2 units to the right and root 2 over 2 units to the left. But remember, these are not just any coordinates. They're actually giving you the cosine and sine of this angle, because eventually you're going to be studying relationship between angles and their sine and sides and etc. Okay, so that's where the root 2 over 2 comes from. Now, just quickly, I'm going to show you the other special triangle. Okay, so I don't want this video to be too long. Let me try to speed it up a little bit here. The other special triangle is the 30, 60, 90 triangle. This is why, here, I'll show you what I'm talking about here. So in a 30, 60, 90 triangle, again, we're looking at hypotenuse of 1. It simplifies calculations. If I'll put the 60 here, but I could have also put the 30 here. It's basically the same triangle but flipped. So this is now just some geometry. In a right triangle, the side opposite 30 degrees, which is half of the other angle, happens to also be half of the hypotenuse. Now, just quickly, you've already seen this. If you type in your calculator the sine of 30 degrees, it's giving you a half. What is that telling you? It's telling you that it's a ratio. It's telling you that the side opposite 30 degrees is always half of the hypotenuse. So even if this was 10 and this was 5, it's still a half. Even if this was 7.8 and 3.6, the ratio would always reduce to a half. Okay, so let me now just go over that again. So in a right triangle with a hypotenuse of 1, this has been proven. Now this is some geometry. The side opposite is always a half. So that's why a half appears a lot on the unit circle. But now what about this side? Again, right triangle, Pythagorean theorem, hypotenuse is 1. This is squared. Half squared is a fourth. We move that over. 1 minus 1/4 is actually 3 over 4. Now that's a nice value, not in the unit circle. No, we have to square root. Also not in the unit circle. We have to reduce. Now luckily, here I'll just reduce it properly. We don't have to rationalize because it already has a rational denominator. And there's our other mystery value. So basically, these are the exact values of sine and cosine of 60 or 30 degrees. We've just used the Pythagorean theorem to solve for them. Now the only difference is that on the unit circle we're using mostly we are using radians. So let me just remind you, I'm going to start with pi over 6. So pi over 6, pi over 6. Pi over 6 is like 30 degrees. So now I'm going to flip my triangle. So if this is 30 degrees, in order for me to arrive at this point, I created a right triangle with a hypotenuse of 1 and 30 degrees. The two other sides, I've already proven, have to be, so now it's just the opposite, root 3 over 2 to the right, and a half. Okay, so I've just flipped. That's why if you look on the unit circle at pi over 6, cosine is root 3 over 2, sine is a half. Okay, pi over 6 is like 30 degrees. So I'll use the triangle here. 30 degrees is pi over 6. Adjacent is root 3 over 2. That's cosine. And opposite is a half. Okay, so I hope you can see that. You can always email me, right? I just hope the video is better than just written notes. And then at pi over 3, which is like 60 degrees, you would have the opposite. Because at 60 degrees, this is actually here, it's drawn here, at 60 degrees, you would have to have traveled a half unit to the right and root 3 over 2 units up. Okay, so I'm just showing you that if this was inscribed on a unit circle, your coordinates would be 1/2 and root 3 over 2. Okay, so your goal is to memorize the unit circle, so you always have it at your disposal in case you don't have a calculator, in case you have to get the exact values of certain angles, you memorize. But of course, you should understand where the values come from. Okay, and then in the next video, I'm just going to quickly show you how to use the circle. Okay, so we'll have a third video. So this was video 1, this was video 2, and this will be video 3.